So let's talk about the determinants in Matlab. So determinants are used in linear algebra and are related to matrix inverse. So if the determinant of a matrix is 0, the matrix does not have an inverse. And we say that it's a singular. So the way we know, we try to calculate the determinant. If it's 0, then it's a singular and does not have an inverse. All right. So let's create like a small matrix, a very simple matrix, okay? And of course, we are talking about square matrices. So we could create a matrix, let's say 1, 2, and semicolon for the second row, row 3 and 4. All right. So this is a matrix. Let's run it. So it's 1 and 2 and 3, 4. So the way we calculate the determinant, so D equals, okay, it will equal, you multiply the diagonal and the first diagonal, so it will be 1, okay, the 1 multiplied by 2, which by 4, I'm sorry, by 4, all right, okay, which is the first diagonal, all right, and minus the 2, the other diagonal, which is 2, all right, multiplied by the 3. So that will give me the determinant of this matrix, which is minus 2, Of course, if you have a small matrix like 2 by 2 or 3 by 3, it will be easy to calculate it, all right, okay, but you know, you don't have to bother because you have a function given to you called dat of a, which calculates the determinant, and when you run it in here, it gave you minus 2. So if you have, like, for example, a bigger matrix, let's say we have a 3 in here and we have 6 in here, so okay, and let's have a semicolon and have 4, 7, 9, for example. So this is a 3 by 3 matrix, as you see in here, all right. So let me delete this. All right, so now the determinant for this matrix is a 3. That means it has inverse. But if the matrix does not have a determinant or the determinant value equal to 0, then it's a singular matrix which does not have inverse, So you don't have to worry about you know about like calculating the inverse, because you have a function to do that. If you need to calculate the inverse, it's a very simple. Remember that we have a function inverse of a, and it will give us the inverse. That's the inverse, 3 by 3 inverse. All right. However, if the matrix is like the determinant of the inverse is like 0, so let's try 1, 2, 3, 4, 5, 6. Let's say 4, 5, 6, and then we have 7, 8, 9, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's try to calculate the determinant of this matrix. It will be 0. Yeah, it will be close to 0. So we don't see it in here because like a long digit. So this is like 0, almost like 0. If you try to calculate the inverse, it will not work. It will not work because the determinant of this matrix is 0. So that's a very important topic that you have to know.